Hello, everyone. I think let's maybe have a kind of recap from the last session. Maybe I think we have couple of minutes to rest of the others to join. So meanwhile, just recollect what and all we have learned. Right? So we have learned the linear regression, and then we have learned logistic regression, right? And what we need to understand, right? It's just conceptual understanding is very much important. If you are able to crack linear regression, you will be almost 40% of the machine learning that you have learned. That's how you need to understand. So these are all very basic things, that we will be piling it up right now. So there are a lot of questions like, do we really need to do coding? And I don't have any idea about coding. uh, you know if you really look at it in such a way, yes, you need to know coding, but not that way you syntactically know everything, right? You just need to aware that has a language, right? The grammar of language, just a kind of a basic understanding that maybe over on the fly you can you can get that. When there is a challenge, whenever something went wrong, then there is a question that what I will be able to do to proceed further. Something is stalled. I don't know what to do next. How I will move. Right. These are all the questions. Basically, most of the time, when we are learning this, vibe coding and all, they will ask this question. So most of the time, right, we should appreciate the uh, technological advancements that is happening right now, and I'm going to help you how to why that the why the last two sessions we have been completely insisting on learning the concepts. Okay, so let me recap the session what we had, and maybe that would help the other people to join by the time. Yeah. So you just need to go to anti-gravity, open anti-gravity, then open agent manager. Actually, your entire program is going to be like on this. There are a couple of advancements that I am going to bring in this program. The people are taking very long time in learning and stuff like that. Coming on such a way that weekly 2 hours that we will be spending so far, and we will be learning in a very slow pace, right? Because that's how we began it. So if you are interested to do this entire program in just 4 days, let's say 2 weekends, 8 hours per day, you need to spend 32 hours, you will finish it off. Okay. And that would be a fast track program that I'm just currently working on it. So in future batches, we will do very fast learning, fast based learning. It means 2 weekends you need to spend 8 hours per day, 8 into 4, 32 hours per day. You finish off of this, 30 hours of program. The first 40 hours you finish it off. So we will be bringing up, some modification and alterations in the pace of the program. That is also, I am working on right now. But what you just need to understand here is, uh, you have started the Open Agent Manager. Go to Open Workspace. I have added a workspace. Let's say Open New Workspace. Click that, and go to my folder Prism. So Prism is nothing but kind of a Python research inside scores, scorecards, models like that. You can understand. Just click on that folder. Now, as soon as I clicked here, I am just letting this the Prism folder, which is comprises of two different content in it. Explore project. I don't have any idea about what this project it is. This is actually something that you just figure it out. There are two files that we have kept. One is the real estate.csv. Another one is real estate IPython notebook. Got it? Now what I'm doing, I'm just running this IPython notebook and trying to inspect. First thing is I'm having the data here, so I'm running whatever that we have done. Now I'm going to show you how exactly you will be able to perform the same analysis without writing any single line of code. Right? Any single line of code. Whatever the concept that we have understood. Now we have understood the concept. Now I'm going to provide you, let me help you to learn this. I'm having a folder Prism. In that I have created something. I just move to bin. Okay. So now I'm having real estate CSV and real estate IPython notebook. There are two I have saved here, and I'm just opening the anti-gravity, and then I'm going to. So as soon as I'm here, this is how it will look like, the data, and then the IPython notebook. Now what I do, I just go here, open agent manager, then I will be connecting the Prism folder. How I did, I just came here, open workspace, Prism, I connected it. So I just delete all the earlier conversations what I had. Now it is connected. Now what I want to tell you here, help me exploring the data. You just say like this, help me exploring the data. So it will understand that what is data, what is the IPython notebook. First thing, it understands that there is a CSV file, that is the data, and it is automatically inspecting the data schema. Schema means the columns. What are the various different columns are there in the data set? Then what it does, it is going and asking you to print and see few rows. You can see what it does. Head command that we have put, that is coming here. Then initializing the exploratory analysis. Whatever we have done there, so generating basic statistics, you can see what and all it does. So Python explore data.py it has created, and it is running the Python file. The file, whatever that file we have created, that file it is creating. And what it does, it is creating all the plots, the charts it has created. You can see what and all it is doing here. Then construct the report. It is generating a report actually. The exploration report.md that is created. Open this, you can see here. The file name is realestate.csv. Total records 414. Columns are 7. Missing values none. And you can see house age, mean, min, and max. You can see the range here. And you can see distance to MRT. And you can see convenience stores. And then you can see here house price unit area, min and max. And you can see here price distribution, the distribution of price. You see correlation matrix, and you see key driver analysis. So it says that distribution of house age to frequency. You see there is a distribution. The next page, it goes to the next one. You see, these are all the analysis it has done. So now you just understood some data. Now I want to further develop the conversation with the bot. Now you know what to do. After exploration of data, you know what to do actually. You should ask, it looks fine. Help me to understand what kind of ML problem that we can frame. You can see here. It looks fine. Help me to understand what kind of ML problem that we can frame. I don't have any idea about what ML problem or anything, right? So if you are not sure about that, it will be able to help you to understand what kind of the analysis that is possible with this data. Analyzing data set for potential ML task. So I am focusing on crafting the problem framing.md. It is creating another document, and it will list out what and all that we can do with this data set. Okay, this is amazing, right? It is telling, you open and see this. Machine learning problem framing. Based on the exploration of real estate CSV, here are the potential machine learning problems we can frame. You can perform regression. This is the most direct and valuable application for this data set. You can predict the house price of unit area, target variable, and then you can see input futures, and you can see why, and evaluation. The target variable is continuous, and user typically want to know the specific value of the property. And then evaluation, what is the evaluation metric? How you assess the accuracy of the model, right? This is what actually the metrics, model accuracy metrics, model performance metrics. So you know what is RMSE, and you know what is the SR2 square root, score, root square score. That's what actually, this is. So root square score to measure how well our model explains the variance in prices. Then what we can do, we can create clustering. We can create some cluster, unsupervised analysis. And we can do classification. If predicting the exact price is too noisy or not required, predict the price tier of a house. So house price of unit area into categories, low, medium, high. Why? Helps in broad decision making. Is this a luxury property? Like that, you can answer certain questions. Recommendation. We should proceed with regression first. It utilizes the full information in the target value. We can always convert it into classical problem later if needed. Now, let me bring up the law. You can see that linear regression dot ipynb. So there is a real estate price prediction IPython notebook. that I am asking it to bring it up. So now checking the existing notebook content, and it is telling that I have found something significant. Okay, amazing. I've got a plan to demonstrate the linear regression, planning, execution, and reporting. And it is going to bring up the IPython notebook and the implementation plan. It says, if you open this implementation plan, it says, this is the notebook already contains a linear regression implementation. I will execute this logic and present the results. So we have provided a linear regression IPython notebook. Whatever the notebook logic that has been there defined in the notebook, it is going to perform for us. You see here, it is performing everything that is written in that notebook one by one. You can see implementing linear regression. Train linear regression .py, now executing it. Files edited, train linear regression.py is a file that has been created. You can see, it is going to execute this. Yes, accept. You can see it has executed it. Then, okay, creating verification report. Yes, accept. It is creating a model verification report, and it is providing you something called a linear regression walkthrough.md. Open. You can see whatever that we have done there, it is doing on its own. You see, I have successfully executed the linear regression model on the real estate dataset. Model performance RMSC 11.16 and SR square 0.55. I could see that the very poor prediction, because the data is not actually linear. Some of the variables are non-linear. That's what we have seen. So now you are asking this, hey, can you justify why the hell the linear regression model is only showing 55%? Now it is investigating the data for reason, right? So analyzing reasons for low R squared value. You see what and all it is going to tell you right now. Creating residual analysis script. You should know what it is. This is actually predicted on the test data set. It is actually creating a predicted versus predicted versus actual analysis. Analysis complete. Plots saved. Model outputs. Checked command status. You see what it does is, it is actually going to create an investigation report. Say okay, accept. Let me see what it does. So model investigation report has been created. You see here, first thing is investigation. Why is model performance low? R square is 0.55, meaning it only captures about half of the price variation. Here is the justification based on my analysis. It says, see, linear regression assumes that a straight line relationship. However, look at the distance of the MRT versus price plot. Observation, the price drops sharply close to the station and then flatten out. So a straight line cannot fit this L shape or exponential decay curve well. It will underestimate price near the station and overestimate them further far away the station. Then key reason 2, residual pattern. A good model should have random errors. There is a pattern. For high predicted prices, the model consistently underpredicts positive residuals. Implication, the model is failing to capture the premium factor of expensive houses. You see that? Real estate prices are given by many factors not in the data set. Maybe floor level, building quality and amenities, interior conditions. So many of the other informations are missing in your data set, like that it is telling. This is hypothetical. The model is underfitting because the complexity of the real world nonlinear price drops, missing features, exceeds the capacity of the straight line recommendation, switch to the random forest regression or a polynomial feature. So to better fit the curve. So it is also telling what is the next analysis that you can perform with this data set. So let me further develop the conversation. See, can you use standardization, scalar normalization, and see any improvement? This is what actually you need to learn. So whenever we are learning on the linear regression class, we have discussed about what is the standardization. Standardization will you know will convert all your real value into Z score, right? I think it is actually for each point away from the mean is what actually the Z score. This is what we have discussed. So now what we were doing, we are asking the bot to standardize the data set and see, right, if there is any improvement. Okay, let us see that. Can you standard scalar? Can you use standard scalar normalization and see any improvement? So now it is running the train data after scaling, right? So after scaling, let's see that if there is any improvement in the linear regression. Okay, Python train scaled regression.py. Yes, fantastic, cool. R2 score is dropped further. Reporting scaling results. Okay, it is creating the report. It is going to generate the same reports. Whatever the reports, scaling experiment results. Okay, fantastic. Baseline unscaled 0.5497, scaled. Okay, fantastic. There is no improvement in the scaled data. That's what we are getting here. So scaling is not improving. Okay. Can you try lasso or lasso and ridge regression? Let us see. There are certain other variants that I'm introducing today that is called lasso and ridge regression. Okay. They call it as L1 and L2 penalty. I will explain that. Maybe I think let me ask the bot to explain that why, or if there is an improvement, why there is an improvement. If there is no improvement, why there is no improvement. Like that, if you ask, it will tell you. So now it is training on the lasso and ridge. Okay, fantastic, cool. So there is no improvement on the linear regression. There is a lasso and ridge. Okay, fantastic. Can you drop the variables which is low in correlation with y target, and also drop those variable which is, here you say low or no correlation, low or no correlation with the target. And also let me first go one by one. Okay, this is what we have done. We have dropped one of the variable. I think the variable which has no correlation, right? I said that the correlation value is 0.05 and below. We drop those variables. So now it is actually trying to drop. Let us see future selection experiment. User requested to drop low correlation futures. I will analyze the correlations of all futures. Fantastic. I have loaded the content. My next step involves meticulously adding the new future selection task to the task.md. Amazing. So it is listing all the task, and it is doing the future selection. Okay, amazing. Accept. So let me see that what it does. So all futures, this is the value. So now after future selection, let me see what it does. Okay. We have yesterday got that, right? There is an improvement now. You can see here, optimized two futures. 0.55 is what we have received yesterday. When in the last session, we have got 0.5539 after removing some futures, right? So now it is matching. So you have to understand, this is what actually you will work with the AI. Okay, the future of your jobs is going to be like this. Anything that you do digitally, you would be able to do with the help of the artificial intelligence. Now the intent to the action, there was some time, right? Earlier when we do manually, it may take a day, or it may take hour, or maybe it may take 1 week or 4 weeks. It doesn't matter now, because it is just a matter of concept that you have learned, and the matter of the sequence that you are conversing with the bot and getting the work done by the bot. So who is ready to do a demo for me? Hello, whatever we have learned so far, somebody has to give me a demo session. Naveen, hello. Dhruv.
Yeah, I'm loading the anti-gravity right now. Actually, I have used once. Let me show you the Kaggle. I have uploaded on Kaggle.
Okay, fantastic. Can you just present me what you have done? Maybe that would be helpful for everyone of yours here. Take 5 minutes. You just bring up the file, and let me know what you guys, if you have tried something.
Okay, so these were most of these were I have actually used in I made using this anti-gravity.
Okay, fantastic.
It's loading. It's taking a while.
So now you guys have learned what is actually linear regression all about, right? I think you have a pretty good idea that what are the steps needs to be performed, right? But Sahita?
Okay, so all of this coding is actually done by the anti-gravity. I haven't done anything in this.
Amazing.
I just shared
Super.
that Google app data stores the data set here.
Fantastic.
So here it
And
actually.
maybe I think, you just need to take, maybe talk through what actually is, going on with this data set. You should see it's not just running the code, it's about the storytelling, right? So what do you have understood? What did you found? Did you find something? Is there any uh, use of this particular data?
So this data set actually contains why some app actually get good ratings on Google App Store.
Right.
So
So
the
how the ratings are really working?
yeah, it's about mostly the rating and what are the apps. It shows the category here. It is loading the data, and we can see this all the columns here, all the reviews, ratings, and installations. These are general parameters. Here is that finding the types of the columns. What are the details of the columns? This is basically clearing the finding the nulls and removing it.
Awesome. Okay. So what did you found in this graph?
So okay, this is the distribution graph. How many actually the apps? How many apps have the average rating here? We can see there's
Okay.
a skewness
So this is
towards
actually
the.
the frequency chart where the count of the application and in which bucket that application higher the count.
Yeah, so most of these
4.5, 4 to 4.5 range. There are more apps, correct?
yeah,
That's
yes,
what
yes.
you understood. Okay.
So this was the category.
Hmm.
With how many number about the frequency of the categories. So we can see the category of
This is a
family
user
apps.
app category, is it?
Yeah, yeah.
Okay.
And here is the binary division about how many are freemium and how many are the paid type of
Right. So
category.
how this paid, uh, I mean, the paid app, say normally everything is free, right? Free app and paid app. Is there any impact of this particular field on your rating?
Not exactly. Here is just about a visualization to understand what is the
Okay.
distribution. Here is an attempted correlation between the reviews and the ratings.
Hmm.
How many people actually putting the reviews based on how many things are been rated here. You can
Okay.
see there are reviews for high rated ones, quite high, actually about 4.5 to 4 5 number of reviews. But mostly we can see here people don't put the reviews; they just put the ratings.
Cool.
So we also understand the behavior of people of what they are doing here, and this is attempted a correlation between. We can see here the reviews are having high correlation with the installs here,
Okay.
and okay, this was just about the paid versions. Again, this is mostly about exploring what are the things inside the data.
Right.
So uh, this is just about how distribution of paid apps. So
Okay.
mostly we have seen that they are free, so we can see the. Uh,
What is that app is more priced? $400, $350 and all?
so okay, I haven't done that one. That part
Okay.
is not shown here.
Right. I think you just need to further analyze that particular range.
Yeah,
So you can ask, whenever you load the data,
yeah,
this is how you need to just, start looking at that, what is there in the data set. Okay. You can see that, there is something that is, looking fishy. There are $200, applications are there. 250 to $400 price range, right? You can
yeah.
see. Ah,
Here is the correlation about the rating and the price.
right.
Yeah, it's okay. They haven't gone into the names of the to these outlier applications. I'll trial that one on.
Okay.
Okay. This is what I actually tried. It suggested this random forest, but I haven't learned these concepts yet, so I am not going into it
Yeah,
right.
we will learn those things progressively. So this is amazing. I think you are able to crack what is a linear regression. That is it's nice about this. Okay.
So actually, I
So
want to ask if these Kaggle learning material is good to refer to learn the things, or
yeah,
should
great.
or
No,
should I?
actually, what you guys need to understand, no, outside our session, whatever the course content that I am actually trying to help you to understand, you have to start, applying this, idea, taking some data, and learning the uh, nicest part. Okay, so always this is not just a kind of the end here. In the sessions, whatever that you are learning, you should start applying it. Okay, and do some research work. See, this is how you learn. Okay, the more that the curiosity, interest, and then it is. See, I tell you, I have been doing this for last 30 years. Almost for 3 decades, we have been not in that blissful generation, right? I have started those days maximum 1 MB 2 MB RAM. You just need to understand this, guys. The file size 40 KB, 5 KB, like that. When the 1992, 94, 95, compact Presario and all, they will work on the floppies. And gradually we have been grown into a giant machines, GB, petabyte, terabyte, zettabyte, like that. We will be talking something. And today, the sophisticated generation is yours. You guys are blessed with the amazing magic wand on your hand. Right? Magic wand on your hand. You should know how to use these magic wands in such a way to develop amazing skills. Right? Coding is absolutely gone out of your hands. You don't need to code. You just talk. Talking is not easy. Hello. Talking is the most wonderful thing. Talk to the machine. Okay. Talk to the machine. Learn how to give command and get the things done what we want. So absolutely right. This is the time investment. You just need to. There is no effort. See what happens. We are having hands-on, and we have a sophisticated tools in place. you know we without much struggle, you will be able to analyze and see what is happening. What writing several pages of, see, 16,000 lines of code I have written in my initial days when I started this career. Today it's just a magic wand. You just need to say that this is what I need. Okay, it will be done. You see what I did. So let's do it for logistic regression. Who will do for logistic regression? Saita, are you joined in laptop? Hello?
Yes, sir.
Okay, fantastic. Open your anti-gravity and load the logistic data set, and whatever I performed, just perform it. We are here to maybe cheer you up, and let me, if you stuck, I will guide you. That's how you learn it.
Okay, sir.
Okay? Yeah, cool. Noor, are you on machine? I think you have some network issue. Guys, please make sure that you, if you don't have network in your place, just go to some coffee day, and from coffee day you start working on this. Okay, you go to some nearest coffee day and you connect from a free Wi-Fi and get the see. Always just make sure that you have the right attitude towards learning. Okay, don't miss opportunities. Go to if you have no connectivity, you don't need to worry. You just go to nearest coffee day and just connect from there and work. Maybe order one cappuccino, drink for 3 hours. He will not ask you to see, leave the premise, right? He won't say. It is most important that how you make use of things, how you spend good amount of time on learning. Today, I think we have only 4 people joined. I think rest of the crowd, I think they are working. I moved it from the morning to evening. I think most of them are beneficial, right? Next, Navin might be. Navin got dropped. Hello. Let me know if you have any problems, Sahita. Hello.
Sir, I'm using another different system, so I'm doing it again from the start.
Okay, okay, fantastic. Dhruv, anything that is something that you stuck, you just struggle, you couldn't make it out, or some such a roadblocker or something that you found. Please make sure that you discuss it in this forum, and I will provide you some kind of help. So always ask questions, right? Make sure that you guys are asking questions. Learning, right? Real learning will happen only when you start thinking and questioning.
So actually, I was looking for specific resource to learn the concept, like what are the things related to, if I say linear regression, what are the attributes
Hey, I
related
have
to it?
already shared you the
Yeah, I have been through the Google developer learning part. I'm
right.
going through one of the that
Actually, I
logistic
just
regression one.
I will upload some of my materials that what I have developed for this program, so that so I don't want to run through like I have initially prepared some PPTs, but I don't want that in such a way that you guys are running through some PPTs in a normal session and how the classroom sessions, lectureships are happening. I wanted you to really work and make sure that see those days, learning the syntax, mugging up and referring and coding, that and all is a story. All are gone. Now you just need to ask right questions. You need to follow through in what way that in what language I am talking. Learn the language, right? This is how how the natural language that we are learning. When we are listening to those language, we will start observing and learning. So the language that what I am talking to the machine, that's the language that you should learn. Everything is magical. Let me, meanwhile, let Sahita to present something. You have any technical glitch? You just let me know, Sahita. Let us recap on logistic
Sir,
regression.
bad network, so it may take some
Okay,
time.
no problem. No worries. I understood that. So let me, present you some of my the next thing. Okay, what and all we have learned, right? We have learned Google ML crash course. Yes. Let me recap everything to you today. Okay. So we have done a foundational supervised learning algorithm used for predicting continuous values. Price is a continuous values. Agree? Hello?
Yes, sir.
Yeah, fantastic. Linear regression models the relationship between features and labels. This is what is happening. Learn parameters that best fit the data. This is what our goal. And this is the formula. Y hat is equal to B plus W1 X1. W is the coefficient, X is the input, B is the constant. That's a bias intercept. You can see predicted value, bias, weight, future. This is what you need to understand. Here, what is that the unknowns are bias and weight. That's what actually the gradient descent is used for, predicting the bias and weight. Okay. Predicted value is the target, X is the input. These two we know. Bias and weight we don't know. This is univariate, one single variable, because there is only one X1, one W1 is there. If there are more X's, it will become multilinear regression. This is univariate regression. Okay? It's a single variable, simple linear regression. You can see model with the multiple future. You can see B plus W1 X1, W2 X2 up to WN X1 like that. Each feature contributes independently. Each has its own weight. Okay. What is the goal? Minimize the difference between the predicted and actual value. How we are getting that? You draw one line and move the line, okay, randomly from from zero to you assign with weight is equal to 0, bias is equal to 0, and move the move that line by 0.01. That's called learning rate. And and we will rotate the line and we will see that in a particular place where the distance between the line and individual values, sum of all the distance between the individual values and the line is less. That is called, okay, mean square value. If the mean square value is the lowest value, then we will be getting that particular line has a best fit line. This difference is quantified using a loss function. This particular function, which is basically accepting the difference and computing the distance and finding out the the least square value. That is what actually the loss function. They call it as loss function. Okay, mean square error MSC is what actually the metric, which is basically for the linear regression. There is a formula for that, and this penalizes larger errors more heavily. Smaller error, if the value is small, it is good. If the value is more, it is bad. I mean, the model is bad. An optimization algorithm used to minimize the loss. Gradient descent, what it is an optimization algorithm to minimize the loss, to find out the best line, where the best line is sitting. For that, this particular gradient descent algorithm is used. Minimize the loss, update weights and bias iteratively, moves parameters in direction of steepest descent. That's why they call it as gradient descent. Okay, and mean square error is what actually the output of that particular loss function. Then gradient descent parameter. There is something called learning rate that you can adjust, and you can adjust how many number of iteration of learning that is actually you can say to the algorithm. These are the two input that you need to provide. Okay. Then future scaling. Why scale the future? Faster convergence, stable gradient descent. Actually, we use standardization. Standardization is the process. Normalization is the process. There are two different methods that normally we will use for this particular scaling. Okay. Then gradient descent parameters. Okay, this we have seen. The key takeaway: linear regression is simple but powerful, works well for linearly separable data, foundation for any advanced ML models. Okay, if you know linear regression, almost 40% of ML you have known. That's what you need to know now. Okay, now let's move to the next slide. Let me open. Okay. So what is loss in linear regression? This is an amazing subject. Based on the earlier discussion, loss is a numerical value that measures how wrong a model's prediction are. What it is? Distance between predicted and actual value. Right? You have already the y, the target y, and what do you do? After training, you just use the test data. On the test data, you run the whatever the best line that you have identified, you just fit that line and you repredict the values, and you find out the difference between the actual and the predicted values. If the loss is less, okay, it is an amazing model. If it is more, it is not an amazing model. This is what actually the problem of minimizing the loss. So loss measures distance, not a direction. Okay, this is the most important thing that you need to know. So it doesn't matter what direction it is. So it is measuring the distance. Two common ways: absolute value, MAE and MSE. There are two different metrics, and squaring the difference. There are two different metrics used to ensure loss is always non-negative. And then definition: sum of absolute difference, L1 loss. Okay, equation is very simple. Sigma of y minus y hat. Y is the actual y that is in that's a target in your training data. Y hat is after fitting the best line, you will be getting the prediction. So that predicted value that you are individually detecting from each target value across the rows. If there are 500 rows, means 500 predicted value you will get. So 500 into 500 minus 500 individual values minus 500 predicted value, then you sigma it out. That is actually summation of y minus y hat is what MAE. And then in this we are actually maintaining absolute values, but here what we are doing, we are doing it for a sample. So divided by the total number of sample candidate, that is called MAE. Actually, MAE is very simple. You divide it by 1/9. The sum divided by n. N is your total number of records. This is amazing. Then L2. L2 is the squared difference, where mean squared error. What we are doing here? You see what we are doing? We are squaring it out. Okay. First you in this particular metric we are removing the sign. That's why we are squaring it. Okay. Then we are dividing it by n. Okay. Nice. And then RMSC is nothing but we are root square of the squared value. Okay. We will figure it out the MSC and we will figure it out the root of the MSC. So same unit has target variable. It's just another representation. So model, okay, equal to 34 minus 4.6x. It means prediction is equal to 23.1. Actually is equal to 24. So loss is equal to 24 minus 23.1 is 0.81. So like that, the individual record loss will be computed. Then the sum of the whole loss will be identified as MSC or MAE or RMSC, like that. So this is actually something a mathematical function. We don't need to much worry about all these things. Okay. Then we will be moving to the hyperparameter. Okay, when we do applied ML, it means that programmatically when we do, so we will be adjusting the you just need to understand that what actually we were doing in the linear regression. The gradient descent is the function which is actually finding out the distance between the predictor and actual, and it is learning slowly and it will be heavily computed. So huge computation it will take, and it will take long time to learn. So they will adjust the parameters. The parameters are amazing. There are two parameters. You can see here, learning rate, batch size. If it is a huge data, every time you can't have memory space, RAM size or page size for the entire data set. If you are working on a somewhere terabyte of the data, then you will have to make it in batches. So there is something called batch size is there. This is just a kind of a mathematically how you compute, okay, within the constraint. For that learning rate, they will adjust the learning rate. So if you put less, it will take long time. If you put more, it will be observed. It will give some quick result, but incorrect. Learning is not proper. So you need to balance the learning rate. Batch size, you need to say it is based on purely hardware. How much is the space that is there in your machine? Accordingly, you need to say the batch size. And epochs. So epochs means how many number of iterations that you need to do for every learning. So not just one iteration. Epochs defines how many iterations basically. So that is something that you need to know. Control step size in gradient descent. N too small means slow convergence. N too large means high divergence. Okay. Goal is fast, stable convergence. So you will find out a balanced value. Okay. And then update rule. This is actually the learning rate minus intuition. This is actually something you need to know. How you figure it out the right learning rate. Gradient magnitude into learning rate determines parameter change. Okay. You don't need to much worry about this. You need to tell that you just figure out the right hyper tuning parameters. Okay. I will get into that actually. I'm going to give you one more depth in the in the conversation. So too small, very slow training. Too large, it is loss oscillates and loss diverges. Batch size, number of trainings example. Okay, how many number of training examples? Every batch, how many candidates in every batch? Processed before updating parameters, trade-off between noise and compute. So if you have million records, 50,000, 50,000, 50,000, 50,000 like that, it will put it in a batch and separately it will train, and finally it will consolidate. That is what this batch training. Okay. So number of training examples processed before updating parameters, trade-off between noise and compute. And then batch size variance. If you see full batch uses the entire data set, stochastic gradient descent, batch size is equal to 1. Mini batch is SGD, compromise between the two. So you can run it in small batches. That is called mini batch. This and all, interesting stuff. Batch size effect. If you take small batch, noisy updates, faster iteration. Large batch, smoother gradients, higher memory cost. Epochs. One epoch is equal to one full pass over the training data set. It is basically iteration. Multiple epochs usually required for convergence. If you increase the epochs, actually it will provide more accurate models. These are also another way you can try out, and you can build some very good model. So epochs versus iterations. Iterations is equal to update per epoch. Iterations is equal to data set size divided by batch size. Epochs control training duration. Actually, once the good model has been reached, you can automatically stop the further learning. So that is called early early termination. That is actually is something possible with this epochs. Hyperparameter interactions. Learning rate, batch size, and epoch interacts strongly. Changing one often requires returning the others. Tune learning rate this is the practical guideline how the industry normally look at it. First they will tune the learning rate, then they will use batch size, tweaking the batch, and then they will monitor the loss curves, and then they stop when loss stabilizers. This is what actually they do. And key takeaways: hyperparameters control training dynamics, learning rates is most critical, batch size is batch size trades noise versus stability, epochs controls training time. Okay, so these are the 4 different parameters that we will pass. So now let us introduce in our example. Let us go to the in this we will say I wanted to implement using grid search CV and come up with best hyper parameters. This is what you need to tell. Okay. So what I'm doing, I wanted to implement using grid search CV. Grid search CV is basically a let's say is a technique that is written in sklan. Okay, you can even say sklan git search cv and come up with the best parameters for the best model can you do the necessary changes. Let's see what it does. I wanted to implement using sklearn grid search CV and come up with the best parameters for the best model. Can you do the stuff? See, optimize models. Okay, you see, it will be able to run all the models that is possible on this particular data set, and it will be able to compare all the models, and whatever the model that is helping you to get the best prediction, it will score those models and it will give you the right model. You see what we have done now. Okay, you just look at that, what it is doing. It is little time consuming. That's okay. See, creating optimization script. You go and open those script and you just learn those script, what the script it is writing, right? This is actually very much important. I have been recording this session, and you watch and you practice it. In the next session tomorrow, I will pick the name. Somebody has to provide me a demo. Okay, will you be, guys? Hello. Let's do this. See, it has done everything, whatever we have done individually, but it has not found out any best model. See this linear regression, lasso, ridge, random forest, and then what? Gradient boosting. These are all the models it has run. And finally it is telling it has not improved anything. let us see the report. Actually, it is writing a report right now. Open the report. You see here, lasso is the one is good. 5497, RMSC 11.1610. This is the best one actually. One lasso. Okay. Linear regression. Okay, not great. Okay, because the RMSC is very less, 10.1 0.01 0.005 here, right? You can see that what the difference here, it is reducing. So it is telling that you can go with this like that. And there is no much differences. You don't need to worry about it. So, it is using the lasso. It is recommending you the lasso, and it is telling that, you can use with the lasso. So, okay. I think, it is ridiculous that, we have so far keeping the old data set of different building type, right? So single bedroom, a small house, and a palace, which is a big palatial house. All these things, there are 544 houses that we are keeping, and we were trying to build a model, some generic model. Generic model means, let us understand that the luxury segment of the cars and the hatchback cars, right? And the middle range sports cars. Different kind of a dynamics between these products. If you are in a real estate business, you will understand. See, the people who are in a luxury segment, the rich people, they don't bother about what kind of the so small things that middle class or lower middle class family is thinking about it. Like they will say electricity connection $60,000 you need to pay. No. We ourselves will take the connection, like that they will tell, right? If you go to the luxury segment, they don't bother investing money, so that always there would be a fundamental differences between the segment of the houses. So what I suggest now, I'm asking this AI engine into the next class what we are going to do. Okay, help me bringing up the data with hidden clusters. This is actually unsupervised learning, correct? Cluster. We are talking about the kindergarten kid, which is trying to understand the data, right? It will only look at size and color, right? That's the same thing that I'm asking it, to do. Help me bring up the data with some hidden clusters. Let us see how the data set is divided. Planning clustering task. Amazing. Fantastic. Find cluster.py. Okay, cool. It is using k-mean cluster. You see here, it is telling there is an algorithm called k-mean cluster. I will tell you what it is. You will, you really find it out in such a way that, how these clusters are formed. You see implementation plan. Okay, I open and see. See proposed changes, prism. Okay, algorithm, k-mean clustering, future latitude, longitude, spatial clustering. Okay, method, use elbow method to find optimal k. Okay, visualization, plot latitude and longitude, plot distance versus price colored by cluster to see if clustering explains non-linearity. Okay, fantastic. Okay, implement. Okay, implement. Go ahead and implement. Because it says exactly there is non-linearity. So if it is linear, we will not proceed with this clustering idea and all. Since we are getting the RMSE only 55, we we will have to look at it in such a way that what else we can do with this data and try to further understand, further investigate the data set. So now we are going and investigating it. What is the pattern? What is there any cluster that is formed in this particular data? Is what we were doing right now. Okay. Now it is actually generated one report, clustering analysis result. Okay, open. You see here, there are 3 clusters found in it based on the latitude and longitude. Okay, cluster are 4 clusters, but I could see only 3. Only 3, right? We are able to see only 3. Okay, there are some 1. See, this is not. This is actually, you just need to understand when I say cluster, right? It is creating 4 clusters, but actually I could see only 3 clusters. I think there are overlap of 0 and 1 here, right? So let us do this way. Let us keep only 3. Why 4? So we would be tweaking that. Since there are a lot of overlaps, we will keep only 3 clusters. Let us see now. It is throwing some errors. Okay. Now it has created only 3 clusters. Let us open and see the cluster results. You can see, right? You have a clear demarcation of area. Okay, green, violet, and yellow. See, now what you need to understand, how do you define cluster? How do you define cluster? Hello?
Plus having similar properties. I mean, not all the properties are
Awesome.
similar, but most of the properties could be similar.
Exactly. Yeah. Actually, there are 2 keywords that I'm introducing now. Okay. That, homogeneous, heterogeneous. See, the data points are homogeneous within the cluster, and it should be heterogeneous between the cluster. Got it? Got it?
So the
There is a
properties would,
exact similarity of the data points within the cluster. So when it is moving, towards upward, the properties are changing. That is the reason different colors have been assigned here. So the idea of cluster is basically, is there any homogeneous group? Homogeneous group. Okay, there are homogeneous group in this particular data set, but there is a problem here. There are, there are some kind of overlaps also between these two. Here this is fine, but these two, there are overlaps. So what we do, let us, I could see there are overlaps in the clusters. Can you help with right approach? See here, I'm just, visualizing and I'm saying, I could see there are overlaps between the clusters. Can you just, figure it out what we can do with this? Prioritizing location-based clustering. Okay. So it is taking latitude and longitude. Maybe that is, let us see, it is, is there any spread across the region? Okay.
So
Initiating
it is
clustering. Yes.
is it
Modifying
doing
clustering script.
so is it choosing the features right now?
Yeah, it is. See, I'm just, letting it do on its own, because I'm not going to, uh, first I'm trying in such a way what the AI is doing. You will understand that why you need, what is the important of this session actually. If AI is doing, people will think that, you know, we can make the AI to do everything. No, unless you ask right questions and, having a meaningful conversation, all are waste only. See, Python finds some clusters. Okay, fantastic. Let us see what it is doing. See, most of the time, right? So we will feel that, okay, everything is AI is doing. Let me ask AI to do. Okay. Actually, you should know what to ask. Actually, that is the most important thing here. Right now, I'm just letting the AI to do whatever the nonsense that it is trying to do it. Okay, let it do. Then we will understand that, how it is different, how it is making difference when we are understanding the right way of asking. Then you can see there is a difference between, how between after this session and before the session. This is how I'm going to keep this. Okay, spatial clustering result. Okay, fantastic. Open this. You see here what it does. Region A, region B, region C. Average price is 30.8, 29.7, 26.9. Count. So it's a purely spatial data, right? And that is the reason, you can see there are 3 regions here. Amazing. This is how the cluster should form. Got it? It's just a child, right? How the child is basically, doing the classification. It is very nearest to the MRT. Definitely, there is, different cluster will form. If it is far away from the MRT, very far away from the MRT, like that, the prices are different. The price ranges are different, like that. Region A, region B, region C. You can see there is a, there are different count and different average prices, special, special neighborhoods, no overlap. And you can see there is no overlap. Okay. So now you understand there are 3 clusters that can be formed here. Okay. There are 3 different clusters can be formed. What we need to do, map the region as part of X and run the uh, linear regression for each region separately. This and all is not possible by human. When you want to do this, you will spend 1 day to code it. Okay. Now it's very simply what I am doing. I understood there are some regions. Okay. You got me some regions. For each region, let us separately run the model. Okay. Let us see. let us understand the, the model outcome of individual region, right? Every region, what is the, how it is, coming out. Then you can keep your prediction for region wise separately. You got it? Hello? You understood what I'm saying?
So first we separated the data. We have got the
Now,
cluster data now.
we identified that, keeping everything together is meaningless. So we will be breaking it into small sectors. So for now, we identified some sectors. Let us see for each region how the model is predicting. Okay. Let us see that. These are all exploration only, just research. This is how the research works. Okay. Now we are going to each and every region and we are running the model for each region. And then, it is providing the region wise regression result. Amazing. Open. You see, the R square value is reducing. You got it? Very poor. The model completely failed here. Okay. And good fit. This is improved. You see, this is improved. Good fits, matches global performance. Okay. We got 40, 55. Now it is coming to 56 and 0. Worse than global. Nice is in this region. Okay. Okay. Coefficient comparison, the rules of the market. Okay. Global model. Okay. The key insights. Okay. Now I could see there is no significant improvement in the clustering strategy. Why not you cluster based on price segment? Okay, clarifying the config data, interpreting user intent. Okay, amazing. Okay, now the region wise, latitude and longitude wise cluster is not helping us, right? I'm not able to, converge with a good predictive model. Now, what I'm doing, I'm asking the, I'm asking the analysis on the price segment. Okay, low, medium, high. Okay, so plan first it is splitting it into 3 segments, and then it is going to run a separate model for each segment. Let us see that. Amazing. Let us see here, sensitivity analysis. Okay, coefficients. This table shows how much the price changes per unit of future change. Okay, key finding. Okay, price segment analysis result. Distance to MRT. Okay, luxury buyers are most sensitive to MRT distance. Mid-tier buyers care the least. Okay, and then convenience stores. Luxury buyers pay a premium for convenience. House age. Reversal. Old luxury homes lose value. Old budget homes gain value. Okay, let us do this way. What we do, you run a cluster k-mean cluster on data set by segmenting. You run a linear regression model separately for each price segment and provide the model result. Amazing. I am now structuring the results for the data. Okay, it is already run the model for 3 segments, but it has compiled something else for us. Okay, we have not said that you provide me the model output result. That is the reason actually it has given us something else. Now we are saying, okay, you provide me the model output result. Yes. So now it is running and it is going to show us, okay, a different output that we are expecting actually. Create a detailed model cards. Okay, amazing. Let us do this. Open. You see here, low price RMS is 4.094. Okay, low due to range restriction. Okay, intercept is okay, amazing. Standard, okay, luxury. This is what the table here, low, medium, high, intercept, coefficient. Okay. So below are the specific regression model parameters for each market segment. Okay. Nice. Can you apply on the test data and show and compare model accuracy metrics? So what I'm telling now, okay, you got the trained results. Now you test it on the model test data, and then you just compare the models. So revising the evaluation strategy. It has given a implementation step here. You can see first split the global data into 80-20, train model, and then train segment models, then evaluate the segmented model. Okay, and then verification plan. Run compare.py, compare global RMSC and segmented RMSC. Expect segmented RMSC to be significantly low because it specializes effectively fitting a piecewise linear function. Okay, amazing. Let's see. The global model with the segmented model. What is there any such a kind of improvement? If we run a model for individual data set for each segment, will that be fine? Is what actually we are asking. Compare segment accuracy.py. It is creating a Python file for comparison. Amazing. Global baseline is this much. You see here, price segmented oracle is 0.9001. What does it mean? Theoretical improvement potential 52.93%. Let's see now. Okay. Okay, edited. So it is telling that it is generating right now, and you can see segmented validation results. Okay, amazing. Let's see here. You see, R score is improved to 0.90. So interpretation. So this proves that linearity holds within segments, but not across the whole data set. Now you need to understand this. This is what actually, as a data scientist, right? Say our journey is like this. Okay, what you just need to understand. First thing is we start with the baseline model, and we will try to find out some clusters, and we will analyze it in such a way that what is the hidden patterns around it, and we used the physical location as a segment basis. That is actually your spatial segmentation, latitude and longitude. It didn't work. Then what we did, we have used the price. Based on the price, we will we classified into luxury separately, and then middle class separately, low budget houses separately. Like that, we have classified into 3 bucket, and we have run that into separate segmented models, 3 different models. Now you can see the score of that 3 different models coming to 0.90. Okay, it means if you are keeping your data set separately for different segments, you can accurately predict your prices, okay, within that segment. That is what you need to know. You don't. So now you need to first get the price and get the classification, then you do the prediction. It would be amazing. So first thing is, after getting the inputs, you need to first classify that into 3 segment. Out of these 3 segment, whether it's a luxury, whether it's a low budget or mid budget. If it is actually luxury, then you should predict using the luxury model for the price. If it is a middle budget, you will have to use the middle budget model to predict the price. Similarly for the low budget models. So this is how the real problem solving using the machine learning. I think so far we are doing great. I wanted you guys come up with a kind of a presentation on logistic regression by tomorrow when you guys are coming. So make sure that you are presenting some of your work, what you did. Okay. Hello. So any questions?
No, such question is not there, but I just want to know how you decided that you should move to the unsupervised part, because
See, unsupervised part is basically, right? I think there is no such a kind of rule, right? This is basically pure, a trial and error, or maybe it is just like practice. The people who start with always unsupervised learning, because without label, you see, is there any cluster that can be formed within the data? So where you will identify if there is a cluster already there, it is not actually meaningful that you generate model. That model is a universal model. You just need to understand the behavior of the behavior of the buyer is completely different. Okay, the parameters that you look at it in a luxurious apartment is not the same parameter that you look at it in the low budget house, right? Correct, no? Hello.
yeah,
Huh.
yeah,
So the determination is basically coming out from your intuition, your practice. You just need to see what you just there is no formulation in such a way that you need to run unsupervised learning and you need to figure it out. Actually, it is a work. That work is a research work. Research work means trying out one more algorithm. You understood? In case if I'm not getting the getting the right right model or right approach, right? So you try plan A, plan B, plan C, plan D, plan E, plan like that. English has 26 letters. Okay, it is purely you need to figure it out a best way where, right, you would be able to predict the prices. Got it?
Okay, so it's not a hard rule for any
Yeah, there is no
business.
such a hard rule for you that you need to you should have to do this way like that. You can do it in a way that is working for you. Today, what we did, we just tried. I know very well that how this real estate pricing works, right? So it is just a domain expertise. If you have domain expertise, you would be able to quickly understand that, okay, what is the issue with this model, why the model is not converging, why the model
So,
is not predicting, because of the generalization of all the segment into one global data set, and you are trying to do trying to fit the formula for universe is not working. When the universe is segmented into three different bucket, each bucket is having its own causes to the price, correct?
if I load a data, let's say, and the first thing I should look it through the domain it is I am working in, because then only
Exactly.
I
See,
will.
what you just need to talk to the people, try to understand that, okay, hey, how this pricing logic work, how you normally do pricing like that. If you ask to a real estate guy, he will tell, okay, you will understand, okay,
Yeah,
these are all
actually,
the
what
fields,
happens?
these are the things that customers are think. See, some customers, some the top investors, real estate property buyers who are buying luxurious properties, if you see, their requirement is completely different. Okay, so what they see, they will look for convenience, they look for the distance, they look for maybe services, amenities. Okay, where you go to the smaller budget houses, it may be far away. It is okay to have a house very far away from the railway station. There won't be any convenience stores are there around us, so that that less price, right? Less price is always having its own costs, right? So how you would be able to compare variety X house with the mix it with the variety Y? So you have varieties, so you first figure it out the variety, and you will be able to figure it out the variance. So in our data set, there are three different variety of the houses are there. So if you build a model for each variety, you would be able to predict precisely. That's what the understanding you should know today.
Okay,
But
so this is the terminology for the feature selection, which is generally used by people, because I have seen this terminology a lot. Of everyone say that it would be the difficult part for do.
they call it as future engineering. That is different thing that what I'm talking. Okay, future engineering, we will come to that that pace some in week, maybe in another 1 or 2 days, you will learn what is future
So
selection.
actually, why I was asking is because whenever I load a data, I can do the cleaning part, I can do mathematical operations, but what I actually have to do to
There is
find
something
each and
called a PCA and FA. We will talk about that. Don't worry about it. If I tell today, you get much confused. I don't want to load so many things in. That's why I'm moving in a very slow pace, because you just need to have some time to work, to gain some hands-on. Right? I don't see that the other people are really putting their effort on doing something. So slowly we will gradually build that.
See, I want to learn this because I want to actually apply it in the business operations part, not just for, I mean, I have to work for my uncle and
It
I
will
have
take another 2 days
some
of
of
time
my
for you,
persons.
because currently we will be this week we will be finishing the clustering. Okay.
Okay.
Next week we will provide one. I will provide you one one small activity which is comprises what we have done, what we have learned in the last last 3 weeks. Then what you do, we will introduce the PCA and FA. PCA is basically primary component analysis, and FA basically factor analysis. If these two, if you have learned, right, then it is amazing. Okay, I
Okay,
think,
got it. Right now we are just doing the technical part. Okay.
yeah,
Okay. Okay. Got it.
right.
Thank you.